Hi, this is Maggie. In this video, we're going to look at another structure in Python that alters the flow of control, the while loop. We will also look at how to generate random integers. To introduce both topics, we'll look over the number guessing program from the text. If we first run this program, you can see that the program is asking me to guess a number between 1 and 50. After I guess, the program tells me if I need to make a lower guess or a higher guess. This repeats until I guess the correct number. The program tells me, "You got it," and it terminates. What's interesting about this program is we don't know in advance how many times the user will make an incorrect guess, so we don't know in advance how many times the program will obtain a guess from the user, compare it to its number, and tell the user higher, lower, or you got it. To write a program that repeats code until a condition is met, in this case until the user guesses the number, we use a conditional loop. A conditional loop is often called a while loop because in many languages the keyword while signals a conditional loop. In our program, after the docstring at the top, we import the random library. It's a fun and useful library. I recommend looking through the documentation on the python.org website to see what's available. Here we will use the random.randint function to generate the number that the user is going to guess. You can see it being used after the variable annotations. The random.randint function takes two arguments, the minimum and maximum of the range. The minimum and the maximum will be included in the range, so we write 1, 50 in parentheses after random.randint, and that will generate a pseudo-random number between 1 and 50 inclusive. Now after that is the loop part of the program. Let's look at the syntax first and then talk about how to construct a loop. We have the keyword while, which is all lowercase, followed by a condition, guess not equal to number, followed by a colon. After that, there is indented code. Here's how a loop executes. Execution proceeds sequentially by default. So execution reaches the keyword while and the test, which is called the loop header. The test is evaluated. If it evaluates to true, we enter the body of the loop, the indented code. If it evaluates to false, we bypass the body of the loop and execute the first line of code after the loop. There is no code after the loop in this example, so the program ends when the loop entry condition, the test in the loop header, is false. So far, it probably looks and sounds a lot like an if statement. Keyword, condition, colon, indented, conditionally executed code. But there is one big difference. At the end of the conditionally executed code, control returns to the loop header the line of code with the keyword while. The test is evaluated again. And again, if it's true, we go back into the loop. If you can picture that, we proceed through the code and then return to the top. It might make sense why it's called a loop. We're looping back to the top. The conditional code here, the loop body, asks the user for a guess and then compares the guess to the randomly generated number and prints one of the three messages. We then return to the top, and if the guess is equal to the number, we exit the loop and the program ends. But if the guess is not equal to the number, we go back into the loop and give the user the chance to guess again. Now let's talk about constructing a loop. there is a variable, or possibly more than one variable, in the loop entry condition that is tested. That variable has to obtain a new value somewhere inside the loop body so that the loop will eventually end. Otherwise, we have an infinite loop, a loop that never terminates. In our loop, that variable is guess. The variable guess is tested in the loop entry condition, and it gets a new value when the user enters a new guess. Now, the user could make this an infinite loop by repeatedly entering bad guesses. But worst case, one hopes, the loop doesn't execute more than 50 times, once for each possible number the user could guess, and ideally it executes about log base 2 of 50 times, if the user guesses in the middle of the possible values left each time. When we're writing a loop, therefore, we need to maintain that loop control variable. First, it needs a value before we test it the first time. Notice that we set guess equal to 0 before the loop header. Then, we need to write a test that describes when we want to enter the loop. In this case, we want to enter the loop when the user hasn't yet guessed the number. And finally, we want to update that variable in the loop. The art of designing a loop is to balance those 3 lines of code, the initializer of a test and the updater, so that the loop executes exactly the correct number of times. You also want to get the order of statements within the loop correct. For example, we could have, instead of initializing guess to 0, given the user the opportunity to enter their first guess before the loop header. If we did that, then there's a possibility the user would guess correctly on their first guess, and the loop would never be entered. If we structure the loop that way, we would probably want to move the "you got it" code to be the first line of code after the loop. If we make it past the loop, we know that guess equals number is true. So we could move that line of code to be after the loop. If we do go into the loop, if the user guesses wrong, we'd want to then give them the hint, higher or lower, first, and get the new guess after giving the hint. So we'd have the same basic lines of code with a few small differences, but we'd have to reorder them to get the program to function the same way. Structuring loops properly so they execute exactly the right number of times, and so they execute correctly, especially on the first and last iterations, takes some practice. Now, before we finish talking about loops, let's write a different sort of conditional loop, one where we know in advance how many times we want some lines of code to execute. Suppose we want to blit 10 stars to the screen in a particular pattern. Your text draws the circular pattern of the aerial fireworks starburst, but let's do something a little simpler, a horizontal line. And we won't do any calculations here to make sure the 10 stars fill the window. I'll leave that as an exercise for you. Here is a shell of a program in which we can implement our star drawing. We import pygame, annotate some variables, and then create the window and load in our little red star image. We have an area for our star drawing code, and then we flip the display and wait for the user to press enter. We want to draw 10 stars, so we want to repeat some blitting code 10 times. If we want to repeat some code some number of times, we can write a little loop, a sort of engine, and then put our code inside the loop, and it will be repeated 10 times. So let's start by writing star num. That will be our loop control variable, equals 0. We usually start loops at 0 if there's no reason to start at another number. Then we write while star num less than 10, colon, and the loop body is star num plus equals 1, which is short for star num equals star num plus 1. It's a quick way to add 1 to a variable, or any number. You don't have to add 1. This is a very typical pattern for a loop we want to execute a certain number of times. Start the loop control variable at 0, test that it's less than the number of times you want the loop to execute, and then increment by 1 in the loop. If you follow that pattern, you shouldn't have an off by 1 error, a very typical kind of loop writing error in which your loop executes 1 too many or 1 too few times. That loop will execute 10 times. It doesn't do anything except increment star num and test it, but we can now put something inside the loop, like blitting code. I have a couple more variables here I'll need to use, x and y. These are the coordinates I'll blit the star to. Naturally, I will want the x coordinate, at least, to change each time I blit. So, before the loop, I can set them to, for example, 100 and 100. And then in the loop body, I'll blit the star to xy. And then increment x by some amount. The star has a width of about 10 pixels, so I'll add 20 to x and see how that looks. If we run the program, we get our 10 stars in a horizontal row. To review the loop that executes a certain number of times, use a loop control variable as the engine of your loop, starting it at 0, testing for it to be less than the number of times you want the loop to execute, and then incrementing by 1 each time through the loop. Inside the loop body, put the code you want to repeat each time. It's possible that something will have to change each time through the loop, like the x coordinate in this example. Find that pattern and make the change in the loop after you've used the variable. The change is for the next time through. To practice with loops that execute a certain number of times, I recommend trying different patterns. Perhaps you can approximate the stars on different flags, such as the US flag, or draw patterns that you like. It will be good loop practice. You could also practice with loops that execute a number of times that is not known when the program is written, by writing other guessing games, or, for example, randomly blitting a star to the screen until it reaches a certain target location. Have fun with it.